Welcome back to COSC 2325. This is the beginning of chapter 3. For this chapter, we're going to get started with coding in assembly language. So we're going to talk about some of the fundamentals with the assembly language. In this video, we're going to look at the basic elements of assembly language, and we're also going to look at an example that adds and subtracts integers. So the first thing I'm going to do is I'm going to set up my system. So I want to show you the steps to set up a Visual Studio program, assembly program. So by now you should have watched the video that tells you how to set up Visual Studio. And in that video, you also saw what I'm about to do and you tested your system. But I'll go ahead and set up a new project most of the time. So I'm going to create a new project. I'm using Visual Studio 2022. So depending on the version that you're using, it might look a little bit different. These are all the projects that I've worked on in the past. I could click on these and it would open the whole project and my source file. So, but I'm just going to create a new project. And I'm creating an empty project. Next. The name of my project, so I'll call it chapter 3. Now, the project name is going to be the folder that's going to contain your solution. So just think about that. You could call anything you want. This is not going to be the name of the file that contains your code. Right here is going to be the location of where this is going to be placed. I have a folder here on my desktop called assembly. And that's where everything's going to go. So it depends on where you want it. So if you want to change that, you would click on the 3 dots and then decide where you can create. On the desktop, you can create a folder. And then from there, you can just click here to create a new folder. And everything will go into that folder that you create. But I'm not going to do that. I'm just going to place it where I have it. If you don't change that, it's going to go to some other folder where probably your Visual Studio was set up. Okay, so I'm going to click create. I want to check. First thing I want to look at is here at the top. See where it says 64? You want to make sure that that's changed to 86. So we're this is the solution platform. And then here on the right, the next step is we're going to set the dependency. So build dependencies and then check MASM. So this means that we're going to be programming in assembly language, specifically MASM, because there are different types of assembly languages. MASM is just one of them. And then we're going to press OK. This step of setting the dependency has to be done before you add a source file. So here, I'm going to go ahead and I have 2 choices. I can add a new item or I can add an existing item, either way. So if I add a new item, it's going to be blank and it's going to put that, this is going to be the source file. It's going to put it in the folder that you just created. Like mine was called chapter 3. If you click on an existing item and your existing item, let's say is on the desktop or somewhere else, then that existing item will stay there on the desktop. So then later you'll have to move it to your folder. So I'll go ahead and add a new item. This extension, when you add a new item, ends in CPP, which is for C++. We don't want that. We want ASM. So whatever you call your file, make sure it ends in .axm. Make sure that the name of the file doesn't contain spaces. You can use an underscore, but you can't have spaces. And then add. So now I have my source file, and I'm able to start typing my program. So let's take a look at, we're going to start typing our program, but let's take a look at all the different parts, explain as we go along. So if you are looking at chapter 3 PowerPoint presentation, if you want to take notes, you can click here to add notes as I go through this one, or you can print them out or take notes somewhere, however you would like. So in assembly language, we have one statement per line. We don't have, like in high level languages, we don't have semicolons like in some high level languages. So we have to put one statement per line. Each statement is either an instruction or it's a directive. So an instruction is going to translate into machine code, and it's going to get an address. And a directive instructs the assembler to perform a specific task, like allocating memory for a variable or creating a procedure. And we're going to look at the different types of directives that we have available. But creating a procedure or prototype would be a directive that we can have in our programs. So this right here, MOV CX5, is an instruction. When we write an instruction, instructions will start with a mnemonic, which is a word that sounds like what this short 3 letters will do. So move means that you're moving a value from one place to another. In this case, you're moving the 5, which is an immediate value. You're moving it to the register CX. We have add. So mnemonics just means that it sounds like what it's going to do, the word's going to do. So when we write an instruction, we can start it with a label. So here it has a label called start. These labels here can be used for jumping. So in assembly, you can jump to a certain part of a program. So you would say jump to start. And so if you're here at this point here, start, you could jump back to the beginning. But notice that label has these square brackets, and the square brackets mean that this is optional. We don't have to put labels in front of instructions. So anything with square brackets is optional. The operands are also optional because some mnemonics don't require any operands. And we'll look at some examples here. This mnemonic, MOV, requires 2 operands. This operand is called the destination, and the second, which is divided with a comma, is called the source. We have a source and a destination. So we're putting the 5 into destination CX. And then we have a comment that is also not required. So this is an instruction. This is a move instruction. This here is a directive. So this is just saying, I'm going to create a procedure called main. And this is how I create procedures in assembly, like functions in high-level languages. Like if you have the sum function, we could have something called sum PROC. So that would be my procedure. Name fields are used for instruction labels or code labels. Name fields are used for procedure names and variable names. Variable names are data labels. So a name field would be this right here. Main is a name field, it's a procedure name. We don't have any variables here. So we can have instruction labels or code labels. This would be a code label right here, start. The assembler will translate names into memory addresses. So this whole move statement right here will get a memory address. Variables will get memory addresses. So there's certain things that get memory addresses and certain things that do not. And then we're going to follow what's called the identifier rules. So to be able to create this word start or main or variables, just like in high level languages, we have rules that we have to follow. So for example, in C++, identifiers have to start with letters. They can start with letters and underscores. You can have letters, underscores, and numbers. In Java, they can start with letters, underscores, numbers, and I believe the $sign. And then they can have numbers in between, but they can't start with a number. So the identifier rules for assembly are the following. Just like in high-level languages, they cannot start with a reserved word. We'll look at reserved words in a minute. They can be between 1 and 247 characters. So they can have characters and these would include digits, and this is how big it can be. Of course, we would never have an identifier that big. We'll try to keep our identifiers small. It's not case sensitive, unlike C++ and Java, that's case sensitive. And the first character can be an underscore, an @, a question mark, or a $sign. So you got a lot of choices of how to begin your variables and procedure names and constants and things like that. But we're going to just stick with beginning with a letter, okay? So what we're going to do right now, before we get to this, is we're going to type part of our program. So let's see here. Here we go. So this is the add to example that's in your book. So we're going to go ahead and pick this program and make sure that you type this program and keep it. We're going to be actually adding it. We're going to be turning it in we're going to add some things to it and then turn it in at the end of this lecture. So at the very top here, you can have your a comment with your name. So the author and date and a description. So then after that, we're going to start our data section. So we have a data section, we have a code section. We'll put some information here at the top in just a second. We're going to have our main procedure. So again, this is not case sensitive. Notice that earlier main was capitalized. In this example, main is lowercase. It doesn't matter. And it doesn't matter if I make it lowercase here. It doesn't matter if I make proc capital. But you will see a lot of the directives capitalized. So you'll see proc, like here, proto and np. You'll see them capitalized, invoke, those kinds of things. So I'm going to keep with that convention of capitalizing these directives. So main procedure. And then here, if I did this and end P, it wouldn't care because it's not case sensitive. So it doesn't care that I have this lowercase and I have this capital. But I like to be consistent. So, and I'm not gonna make you follow any specific conventions with assembly, okay? So this is a procedure. So we have main procedure. This is where my main procedure ends. And then if I wanted another procedure, like let's say, I had a sum function that I wanted to add, then it would be sum procedure. And then this is how I would end it. all my procedures will be defined under main. And then at the end, to end everything, to end the whole program, like the close curly brace of a class or something like that, then we'll put end main. So this actually is ending the everything. This is the procedure. This ends the program. Okay. In the data section, we're going to define our variables. The code section here in main, we'll put code. And here, if we have a function, we'll put more code in between those two. I'll just say code instructions. So this is where my instructions are going to go. Now, since I'm programming for 32-bit processor, I'm going to need some special lines up here. So .386.model flat and the stack line, these are required. These 3 lines are required if you're doing 32-bit processing, 32-bit processor. So if you're programming for a 32-bit processor, and then this one is needed no matter what, exit process. And this invoke, it goes with this, it matches with the exit process, and I'll explain that. So let's start with the .386. So the .386 is actually saying that I'm going to be programming to show you how the information here. So it's a directive, and it identifies that this is the 32-bit program that can access 32-bit registers and addresses. So remember, the registers are on the CPU, and so this is saying my program will be a program, a 32-bit program. I only want to access 32-bit registers. So that's why you don't need that if you're doing 64-bit programming. Then here, the next line is model flat std call. So type first, std, standard call. So model flat is the memory model that is linear in design with no combined segment or offset addressing. So it's just saying we're going to have a flat model of of the memory that we're going to be using for this particular program. And std call is talking about how parameters are going to be handled by these procedures. So when I create this sum procedure, right now this procedure doesn't have any parameters, doesn't have any local variables, but if it had parameters or local variables, std call says how to handle those. It also will dictate how these local variables and parameters, whenever you pass something to a function, those parameters get put on a stack. And I'm going to show you what the stack looks like in a little bit. But a stack, just think of it like an array. But std call is going to give us the rules on how to clean up that stack. Okay. I'm going to go back to this in just a minute. We're going to look at a stack and we'll talk more about this. But it's basically saying, how am I going to manage the runtime stack when procedures are called? So, and we'll look and see what we mean by that. And we're really going to get into this in more depth in chapter 5 when we work with procedures and pass values to procedures. Okay, so that's this line. And then the next line is going to be the stack size. So we're managing using this type of management, which by the way, STD call is how we in C++, that's how procedures are managed. This right here tells me the size of my stack is going to be 4,096 bytes. So we'll put here dot. Some stuff. Okay, so dot stack and 4,096 bytes. So let me talk about the stack for a second. So the stack, I have an image here of what the stack would look like. So you can imagine the stack to look like an array, except we usually look at an array horizontally. We're going to look at it vertically, going up and down. Let me get a pencil here. When I have a function in a high-level language like the function sum, and I take this sum and I pass it two values. Let's say I pass it the A and B. When I pass it those values to the function, there's got to be, well, first of all, these values go onto this stack, this runtime stack. So I'm going to draw my runtime stack over here. There's got to be a rule that says, well, do I put A on the stack first or do I put B on the stack first? So the CPU has to know like which one is getting first, the A or the B. And so in this case, STD call says that it's going to put the parameters on the stack starting with the last parameter. So B gets put on the stack first, and then A gets put on the stack. And basically what we're putting is the value. I put the letter B and the letter A, the variables, but if B contained a 5, the 5 would be put there, and then the value of A would get put there. Now the way that stacks work is whatever you put on the stack last is the first thing that comes off the stack. And we call it a pop. So we would pop this last item from the stack first. There's something that's called ESP. ESP is one of those registers that I mentioned before in a previous chapter. So ESP is the stack pointer. So it's keeping track of where we are on this stack. What's the last thing that got put on the stack? Oh, A got put on the stack last. If I take something off the stack, that A is going to be taken out first, and then this ESP pointer is going to move up. So if I take A out, ESP, so if I pop A, ESP would now be pointing here. The other thing about STD call is that when you have a function, it doesn't matter if it's low level, like in assembly or C++, like in this example, it tells us how to manage, it tells us another thing on how to manage the stack. It tells us that when you're done with this function and you're here, you're about to return back to where you came from, this pointer, this ESP needs to be at the top of the stack. So it's got to manage that. It's got to clear the stack, and clearing the stack just means that you go back to the top of the stack. If you only have one function, you go back to the top of the stack. And if this doesn't make 100%, if you're not like super clear about this, that's okay, because we're going to talk a lot about this in chapter 5. But right now, I just want you to understand what that line means. Okay, let me erase all this. So the stack size is, so we just looked at the stack, so that that stack size is going to be 4,096 bytes. And because this is 32-bit programming, each, you could call it element of the stack, or each location is going to be 4 bytes. The other thing is, like, if we have a function that's recursive and we don't exit that recursive function, and the function keeps calling itself and keeps calling itself, and we forget to stop it, then that stack would get full and it would overflow. But we typically don't see the stack getting full. That's why we set it at 4,096. We shouldn't have that much on the stack. And then again, the operating system initializes ESP. And I didn't say this earlier, but it initializes ESP to the address of the first byte above the 4,096. So in this picture, ESP would begin up here before. This would be the top of the stack, where it would start here. All right, so we have our stack size, how we're going to manage the stack, and then we have one more line. Okay, so we have a prototype, a function prototype. So we have exit process. Exit process is a function that's defined already, so the assembler knows what it means. It's not something that we're going to define. PROTO it stands for prototype. If you remember in C++, when you had a function, the prototype was the header of the function with a semicolon at the end, and you would put it at the top. So this is what that means. This is a prototype. Then there's a comma. Then their DW exit code is just the name of a variable. You could change that to a different variable name. And then this is the size of the variable. And then here, invoke exit process 0, this is where we call the function. So in high-level languages, you know, where you say return 0, this is that same concept. You're saying, I'm returning 0, so everything went okay. I'm at the end of the program, everything went well, and I'm returning 0. So right here, we're going to put exit process. Now, again, exit process can be lowercase or all capital. And then this is the prototype, so proto. Then there's a comma. Then in this example, it says DW exit code. That's just a variable. You could call it ABC if you wanted. Doesn't matter. But it's a size double word. Double word can be lowercase, capital, or a mixture of both. And then, so that's at the top before the data section. So you have those 4 lines. And then to call this, it's going to be when you're ending your main. So right here, invoke, that's at the end. So think of this as a return 0. Invoke. And to invoke just means call. Go make this do what it's supposed to. And then so we're calling the function. This is the name of the function, and it has one parameter, and the parameter is 0. So you put a 0 there. Again, these don't have to match. Invoke is typically capitalized, but I just want to show you. I'm going to run it, and then I'll make it, by convention purposes, I'll capitalize all that and make it nice, but just want to show you that you don't have to capitalize everything, and it's going to work fine. So this would be your template, what you would want to keep. I would just keep this ASM as a template. And I went ahead and added this example1.asm to your Canvas. So, you know, at any time, if you need it, you have it there. You can download it and copy it. So everything worked. So you know that it worked because notice here that it says at the bottom, it says exit it with code 0. The other thing you know that it works is you get the console window, which right now was behind Visual Studio. So the console window here says exit it with code 0. If later on you're going to need your console window, if you can't find it, it's going to be behind Visual Studio. And if you look down here in the bottom where you have your where you pinned certain applications, you will always see it there if you just currently run a program. Okay, so I can just click that and look at it. Okay. So the next thing we're going to do is we're going to just write a little program that moves some values. We're going to use add and subtract. I'm going to take out the sum procedure because I'm not using sum procedure yet. I'm not using procedures till chapter 5. So here I'm going to say move. I'm going to move something into EAX, the number 10, and then I'm going to add to EAX the value of 6. So the next thing that we're going to do is we're going to look at the registers window. So to do that, you cannot look at Windows, at debugging Windows, without being in debug mode. To be in debug mode, you need to set a breakpoint. Before I set a breakpoint, I'm just going to run. I added 2 lines of code. So I always want to just run to make sure that whatever I added, I didn't make any mistakes. So I didn't make any mistakes. I'm going to go ahead and put my breakpoint here at line 17. Because my breakpoint is at line 17, it means that line 17 is not going to execute. It's going to stop before it runs line 17. Now that I put a breakpoint, I'm going to run my program. And I was looking at some other stuff earlier. You probably are not going to see this window. So I'm going to close it. This is probably what you're going to see the first time that you run it. And so to look at that registers window, you're going to click on Debug, Windows, Registers. You're not going to see these options. So I'm going to stop debugging, okay? I'm going to take off the breakpoint. If I am not running my program in debug mode, look at my Windows options. It gives me 1, 2, 3, 4, 5 options. So if you get that, it means you're not in debug. So put it there, run it, debug, Windows, registers. I'm gonna click on registers. It's going to show you all my, it's going to show you the registers window. And right now here's EAX. And EAX, that value in there is garbage. It's getting garbage from the register left behind from something else. So when I execute this next line, the 10, I'll see a 10 in my register. And I'm going to see 10 as hex. So I see an A. A is hex for 10. When I execute the next line, it's going to take the 6 and it's going to add it to the 10. So it says add 6 to the 10. And then it's going to store the 16 in EAX. So, and the add operator, this and the move also, EAX here is the destination, and it will get updated with the sum of 6 and 10. So it's adding 6 and EAX and storing it in EAX. Now, 16 in hex is 10. It's really confusing. So I might see how it says 10 right there. So let me just show you. If you have, we know that 15 is F in hex. So if you, and this is 16, right? So if you add 1, F plus 1 is 16. So this would be 0, carry 1, and 1 plus 0 is 1. And the reason we carried is because it's base 16. So you're going to carry, when you hit 16, you are going to carry that 16 over. So 15 plus 1 is 16. So that's 0, carry 1. If I do f plus 2, it would be 15, 16, 17. So 17 minus 16. Second. It's going to equal a 1. So I'm going to put a 1 here and carry the 16. So this right here, this 16 that I subtracted is the one that I carried right there. And so now f plus 2 is 11. So this is hex 16, this is hex 17. And that's why you see a 10 right there, because it's 16. Okay, so I did the add, and then now here at this line, I step through these two statements. I'm at the invoke, so it's once I step through that one, then it's going to exit my program and be done. But I can see my 10 in EAX, which is the sum. So I'm going to go ahead and clear everything. And then I'm going to stop debugging. So once you stop debugging, then you can go through and add more code and execute again and test it. So the next thing we're going to do is use the subtract instruction. And so now that I've added 16 or added 6 to 10, I'm going to subtract from EAX and I'll subtract 2. So at this point, I have 16. I'm going to take 2 away. So it's going to take 2 away from EAX. And I should see 14 in EAX. So I'm going to run it. There's my registers window since I already opened it. I'm going to step through it. I have 10. There's my 10. Now it's going to add 6. So now I have, this is 6 in hex. And it's going to subtract 2. So that's E. So 14 in hex is E. Now, if the hex is confusing, you can look at these values in decimal value by using the watch window down here. So here I can type EAX and I can right click on value and change. I can unclick where it says hexadecimal display and it changes it to decimal display. So I'm going to run it again, and I'm going to have the watch window open and the registers window open. So here's watch. Watch, this hex number here is in decimal down here, which is the garbage that it grabbed. Then I'm going to step to the next line, and it moves 10 to EAX. So in the register, I see an A. Here I see the decimal value. Now I added 6, so you got 16 in hex, 16 in decimal. Now you added 2, so subtracted 2, so you have 14 hex here, 14 in decimal in the watch window. So the watch window is really useful because you can see things in decimal and you don't have to convert from hex to decimal if you're dealing with decimals here on this side. Okay, let's see. Okay, so I'm going to go back to the top where we left off. So we looked at, we were looking at how to define these. These are all the different rules. So the next thing that it talks about is the different mnemonics and operands. So here's some examples of some mnemonics: move, add, subtract, multiply, increment, and decrement. We have operands for these. Remember the operands is what you, so a move has two operands. So I said move 5 to EAX or move 10 to EAX. So your operands can be constants like a 5 or a 10, an expression like 8 plus 9. It can be a register or it can be a data label. And a data label is like a variable in a high-level language. Constants and constants expressions are often called immediate values, and that's what I'll call them. So this right here, 8 is an immediate value. In this case, in our example, 10 is immediate value, 6 is immediate, 2 is immediate. And the reason they call it immediate is because the CPU doesn't have to go get the 10 from memory in RAM. The 10 is just available to it. It's immediately available. We don't have to go to a memory location. So we don't have to go to the register EAX, or we don't have to go out to RAM to a variable. We haven't created any variables yet. Here's a mnemonic that doesn't require any operands. So STC, it just sets the carry flag. So later on, we'll see why we would do that. But all this does is if you add this to your code, it turns on the carry flag. We'll look at that one later. This increment just requires one operand. So this will increment EAX by 1. This will increment my byte by 1. EAX is a register. My byte is a memory label or location, like a variable. And then here, these are some examples using 2 operands. These words right here will be in your quizzes and tests. So the first operand next to add or subtract is the destination. The second operand is your source. So ECX gets added to EBX and then stored in EBX because it's the destination. 25 gets subtracted from my byte and gets stored in my byte, etc. And the next 2 slides is talking about comments and how we can write comments in assembly. So I showed you one way by just using the semicolon. The other way that we can write comments is by using the keyword comment, and then you can pick any character here where you have the @ sign. Just pick a character that you're not using in your code. So here's an example. If I wanted to put all this in a comment using the comment directive, I would say comment, and then I can pick any character, but I cannot pick the dash because I'm using the dash in my name. I'm using the semicolon here. So I could use the @ sign, or I could use this exclamation point. And exclamation point. So I can comment a whole section by using the comment directive. Look really quickly. See what we've accomplished. Okay, so we're gonna stop this example here, and what I want you to do is go ahead and turn in this example. So it'll be exercise 1 that you'll type, and you're gonna have these 3 lines. Make sure that what you turn in has the comments at the top. So what you're gonna do is the following, okay? You're gonna create, because you're gonna also turn in a screenshot of the registers. So create either a Word document or a Google Doc. You're going to paste the source code. So copy that into your document. And if you want, you can get rid of, the way you can get rid of this double spacing is by clicking right here, line and paragraph spacing, and saying remove space after paragraph. So this makes it nice and tight. And then at the bottom here, you're going to put a screenshot. I want you to show me the EAX register after we've subtracted. So when it has the value of 10 minus 6, 16 minus 2, which is 14. So you're going to run your program, put a breakpoint, run it, look at the registers, step through it. I'm clicking up here, by the way, to step through it. So right now I've got a 10, which is 16 in hex. And then I want to see 14. So I want to see that E right there. So what you're going to do is, I'm just going to highlight the E so you can see it. Wait. Well, it's okay. You don't have to highlight it. We're going to take a screenshot of that register. So you're going to click on Windows Shift S. Windows Shift S. And don't take all the register. I don't want everything. I just want to see EAX containing the final value, the 14 hex. So once I let go, if you do Windows Shift S, it crops that area and it puts it into your clipboard, and then you can just paste it. So right click paste or Control V for pasting. So there I can see. If you make it too big, it's really hard. I want to be able to see the register, okay? So you have the code, and then of course make sure it has a date in the description, and then you have the register there. And that's what you're going to turn in for this exercise 1. So I'm going to go ahead and name it. Exercise 1. Give it any name. I don't really care what name you give it. I just like to name my files with last name, first name. Make sure you figure out what location you're saving things. So I'm going to save it to my desktop. And I have an assembly language. I'll just do the desktop and then click save. And then you'll submit this. Now, the other thing I want to show you before I finish this video, so submit this, is the folder. Hold on, let me stop this. So this folder here that says assembly folder, this is where I put my project. I name my project chapter 3. This is the one that I did right now. So if I open chapter 3, there's my example 1 ASM. And the only reason it's in the folder is because I did new, add new. So it added to here. Later, we'll be importing files, add existing. It's going to work a little bit different. But if I were to close this and I wanted to open this again, and I'm like, oh, I want to run that program that I just did in class. Okay, so I'm going to open here, open chapter 3. The file that you click on is the SLN file. Don't click on the source file. That's not going to set up all the dependencies and have everything all nice and pretty. So you got to click on this file. So I click on that file, and then I'm able to run my program, making sure it's set up to 86. I can just click run. Right now I have a breakpoint. I can run my program. Okay, so just remember, run SLN file. Open. And right now it's opening with the wrong Visual Studio. So, but you can run it if you do the this is my enterprise. You can run it if you click on this one. If you click this one, it's going to give you errors. Okay, guys, good luck. Let me know if you have any questions. Send me an email. Thank you.